Namaskar, I am Anand and you are in the live class of Joint for Education. In this class, I am going to derive the expression of electric field at a certain point due to the electric dipole. Let's start the class. So, in this class, I am going to derive the expression of electric field due to dipole at point when the point is on the axis when the point is on the equatorial. So let's see the relevant figure for this expression. There is a dipole and O is the midpoint of the dipole. At A we have minus Q charge and at B we have plus Q charge, and there is a point P at a distance R from the midpoint of the dipole. So the distance of the point from A it will be the separation of the dipole is 2a, therefore AO equal to A and BO equal to A, therefore AP equal to R plus A and BP equal to R minus A. After there is no problem to understand the figure. So this is the AB is the dipole at A minus Q charge, at B plus Q charge. There is a point C at which we find out the electric field due to this dipole. So we write down here, consider about a dipole AB of length 2a, and O is the midpoint of the dipole. There is a point P on the axis of the dipole at a distance r from the midpoint of the dipole. At P, we find out the electric field. For this, we take the help of the Coulomb's law as well as the superposition principle. Let's consider about the direction of the dipole, which is minus 2 plus direction of the dipole will be A to B, and the electric field at P due to A or minus Q charge here will be P to A, and electric field at P due to plus Q charge, this one will be B to P. Hope that there is no problem to understand the direction of the dipole and direction of the field at P due to the minus Q charge, and direction of the field at P due to the plus Q charge. So at last we find out what is the electric field at P due to the dipole. So separately we find out electric field at P due to minus Q charge as well as due to plus q charge, and finally we add electric field at P due to the dipole equal to electric field at P due to minus q charge, and electric field at P due to plus q charge. So let's see one by one, and note down these statement. After 2 minutes, I will start to develop the class. Of that, all of you noted down. So we write down here electric field at P. And this is the cap P. Cap P clear the direction of the dipole from minus q charge to plus q charge. Cap P. Of that there is no problem to understand up to this step. Similarly, we find out electric field at P due to plus q charge. So after there is no problem to understand up to this step. So finally we write down here electric field at P due to dipole equal to electric field at P due to minus q charge plus electric field at P due to plus q charge. Suppose this is the E minus Q, and suppose this is the EQ. So this one will be E minus Q plus EQ. Now putting the value of E minus Q and E plus Q. When r is far greater than a, then r square minus a square will be r square. So here will be r to the power 4. So we cancelled out this one. Then we get here cancelled out this one. Then we get here u a y y epsilon naught into r to the power 3. So hope that there is no problem to understand the expression of the electric field due to the dipole at a point P when the point P is on the axis. So note down. So in this class, I have derived the expression of the electric field due to dipole at a point on the axis. For this, we consider about we take the help of this figure. This is the details of the figure. Consider about the dipole AB of length 2a, O is the midpoint of the dipole. There is a point P on the axis of the dipole at a distance r from the midpoint of the dipole. At P, we will find the electric field due to this dipole. For this, we take the help of Coulomb's law and superposition principle. So electric field at P due to minus P charge, this one, and cap P indicates direction of the dipole from minus Q charge to plus Q charge. So electric field at P due to plus Q charge, electric field at P due to dipole. Now putting the values of E minus Q and E plus Q. After the simple calculation, we get this one. So half that there is no problem to understand the explanation of this derivation. In the next class, I will write the electric field due to dipole on the equatorial of the dipole. Till then, thanks to all of you. Thank you very much.